Hi, it's Professor Jones. Let's take a look at more on slope from section 2.4. The objectives are to find slopes and equations of parallel and perpendicular lines, to interpret slope as rate of change, to find a function's average rate of change. If two non-vertical lines are parallel, then they have the same slope. If two distinct non-vertical lines have the same slope, then they are parallel. Two distinct vertical lines, both with undefined slopes, are parallel. Let's write an equation of the line that passes through -2, 5 and parallel to the line whose equation is y equals 3x plus 1. So we want to express the equation in point-slope form. Well, the given line equation is y equals 3x plus 1. This means the slope of the line is 3. So a parallel line will have a slope of 3. So y minus the y coordinate of my point, which is 5, equals 3 times the quantity x minus the x coordinate of my point, which is -2. So I wind up with y minus 5 equals 3 times x plus 2. And in point slope form, that's actually the equation of my line. So let's talk about slope and perpendicular lines. If two non-vertical lines are perpendicular, then the product of their slopes is -1. If the product of the slopes of two perpendicular lines is -1, then the lines are perpendicular. A horizontal line having 0 slope is perpendicular to a vertical line having undefined slope. Find the slope of any line that is perpendicular to the line whose equation is x plus 3y minus 12 equals 0. Well, I'm going to take this and solve it for y as my first step. So I add a 12 to both sides of the equation. Now I need to divide each term by 3 to isolate the y. So the slope is -1/3. And the slope of any line perpendicular to this line is going to be 3. Slope is defined as the ratio of the change in y to a corresponding change in x. It describes how fast y is changing with respect to x. For a linear function, slope may be interpreted as the rate of change of the dependent variable per unit change in the independent variable. In 1990, 9 million adult men in the U.S. lived alone. In 2008, 14.7 million adult men in the U.S. lived alone. So we want to use this information to find the slope of the linear function representing adult men living alone in the U.S. Express the slope correct to 2 decimal places. Describe what it represents. We formed the ordered pairs 1990, 9 and 2008, 14.7 based on the information that we were given. So we use these ordered pairs to find slope. So we look at the difference in the y values, and that's our i's, and we put that over the difference in the x values, and we know that whichever y was used as the start of the subtraction in the numerator, then the x corresponding to that y has to be first in the denominator. So we'll take our change in y over our change in x, and we get approximately 0.32 when we round things down to 2 decimal places. So the number of men living alone, according to this model, increased at a rate of 0.32 million per dollar. Million per year, I meant to say. So the rate of change is 0.32 million men per year. So that basically means that every year approximately 1/3 of a million more men live alone than did the year before, according to the information we have. Let's look at the average rate of change of a function. Let x1 f of x1 and x2 f of x2 be distinct points on the graph of a function f. The average rate of change of f from x1 to x2 is f of x2 minus f of x1 over x2 minus x1. So let's use this concept to find the average rate of change for x cubed, f of x equal x cubed, from x1 equal -2 to x2 equals 0. So basically, I'm going to replace all x's with the given values. So x2 is going to be replaced with 0, x1 with -2. And I'm going to find f of 0, subtract from that in the numerator f of -2. But f of x squares its input, cubes its input. So I'm going to cube 0 and subtract from that the cube of -2. So this turns out to be 8/2, which is 4.